Okay, hello and welcome back. In this video, we are covering section 10.4. So this will complete our exploration of the conic sections with the hyperbola. So let's take a look at what they look like, what the formulas look like, and get some practice with a few examples. So hyperbola, let's draw an example here. Kind of looks like two parabolas that are symmetrical to each other. And I'll draw this first one with it oriented at the origin. The center will be at the origin. So it will have two vertices. You can place them here. You can call this vertex 1, vertex 2. It will have two focus points. So I can imagine a focus 1 here and focus 2. And so we'll get two parabola-like shapes opening towards the two focus points. So something like this. And I'm showing this oriented horizontally, where they're opening to the left and to the right. But they could be flipped where they open up and down. So we'll see the difference in the formulas. This axis that contains the focus point and the vertices, so we had called that the major axis for ellipses. In hyperbola, this is called the transverse axis. And then the other axis that goes through the middle is called the conjugate axis. So let's look at the written definition of a hyperbola. So it says a hyperbola is the collection of all points in a plane, the difference of whose distances from two fixed points is constant. So it looks similar to the definition of the ellipse, except we have the difference of these two distances instead of the sum of the two distances. So what this means is if we have some point, so some point um, on the hyperbola, we could have one distance from the first focus point. So I can imagine, I'll make this line up more, some distance coming from our first focus point, and then the second distance coming from our second focus point. If we subtract those two, that value will be the same for any point on the hyperbola. So just to show the general equations already before we see some examples, it looks very similar to the equation of an ellipse, except we have a subtraction in between terms instead of an addition. So what I mean by that is we could have x minus h squared over a squared, and instead of plus, it has a minus. So minus y minus k squared over b squared. So this would be a hyperbola that has a center point hk. So we would call this center point, it's not a point on the graph at all, but it's in between the two vertices. So for instance, this would be our center point. So if the x comes first, notice we have the x term minus the y term, then it's oriented in this way, where the parabola is open to the left and to the right, where the curves open to the left and to the right. If it's in the flipped orientation, we would just see the y term first. So this would be y minus k squared over a squared minus x minus h squared over b squared. So let's define what a and b mean in this context. So let me draw another picture. So we have our two vertices. Our focus points are on the same line as the vertexes, but on the outside. So these values A and B, maybe I should write it out first. The value A is the distance from the center to the vertex. The value C, which we don't have in the equation, but um, that would be the distance from the center point to the focus points. So similar to our um, ellipses. From center to the focus. So we have a similar statement involving c squared, a squared, and b squared, except for hyperbola, it's c squared equals a squared plus b squared. For ellipses, we had a subtraction here, a squared minus b squared. So for hyperbola, it's a plus. So we'll use this one if we're just given an equation in order to find out where our focus point should be. So this distance would be our distance A. B gives you the distance from the center point, but it doesn't go to any point on the hyperbola, like it won't go to another vertex. But we can imagine it creating a box. So I'll show you what I mean. So this distance is A from the center to the vertex points. So we can imagine whatever the B value be, we can go a distance in the perpendicular direction, and however far out that goes, so this would be a distance of B, you can imagine it creating a box with the vertices. This would be the same distance B going downwards. So hyperbola have two asymptotes that are like crisscross with each other that go through the center point and they go through the corners of this box that's created. So we can use this box as a reference to visualize the asymptotes. We'll define them using equations in a later example. But this allows us to see where the curve will be bound. So from my vertex points, I can now draw my curves going outwards and approaching the asymptotes. So I'll be using this method because we can get the A and B value from the equation. So I'll be using this method to help graph these more easily. And then, as I mentioned later on, we'll define the equations of these asymptotes as part of our description of the properties of the hyperbola. So we'll start as before with looking at hyperbola that are centered at the origin. So imagine h and k are both 0. So we'll just have x squared and y squared show up in our numerators. So that's our first example here. So this will be equations centered at the origin with the transverse axis along the x-axis. That means we have this situation where the hyperbola is opening up horizontally to the left and to the right, which means that we should see the x term first. So again, if x is first, we get this kind of shape. If y is first, we get an upward and downward hyperbola. So let's start first with x squared over a squared minus y squared over b squared equals 1. So we'll get this sideways hyperbola opening to the left and to the right. So example 1 has us find the equation of a hyperbola with the center at the origin. So I'll say center is 0, 0. One focus is at 3, 0. And one vertex is at negative 2, 0. So let's start to visualize what this will look like. So center is at the origin. I'm going to make these a little more evenly spaced. We have a focus point at positive 3, 0. 1, 2, 3. So that tells us that's a distance of 3. That would be our C value. So I'm just going to make a note of that. C is equal to 3. And we have a vertex at negative 2, 0. So that distance from the center point to the vertex, in this case it's a distance of 2, that will be our A value. So I'll go ahead and write that down. And everything should be symmetrical, so that means if I have a vertex at negative 2, 0, I should have another one at positive 2, 0. And if I have a focus point at 3, 0, I should have another focus point at negative 3, 0. So we have our A and B value. Let's find out, or I'm sorry, our A and C value. Let's find out what B should be equal to. So we'll use the equation C squared equals A squared plus B squared. So that means B squared will equal C squared minus A squared. So that would be 3 squared minus 2 squared, or 9 minus 4, which is equal to 5. So B squared is 5. That means that B is, to take the positive root, the positive square root of 5, which is like just over 2. It's like 2.1 something, I think. So if I'm going to graph this, let's graph it first and then build the equation. We have our vertexes, which is the outer edges of that box. And the B value will tell us how far to go above and below the center point. So it's like a little more than 2. So something up here and then going 2 units down about here. So I can draw this imaginary box. That means our asymptotes will crisscross through this box. So we should get some kind of curve roughly like this. So we'll curve out and approach the asymptotes. And then let's build the equation. So we should be in this form, x squared over a squared minus y squared over b squared equals 1. So we should have x squared, a squared would be 4 since a is 2, minus y squared over 5, because we said b squared was equal to 5, equals positive 1. So that will be the equation of our hyperbola, and then we have a graph. All right, let's now start with an equation and figure out all of its attributes and plot the graph. So here we're starting with x squared over 16 minus y squared over 4 is equal to 1. So I don't see anything added or subtracted to our x or y variables, so that tells us that the center is at the origin. Our a squared value is 16, so that tells us that a is equal to 4. Our b squared value is 4, so that tells us that b is equal to 2. So just with these pieces of information, we can actually produce the graph because we know the center and we can figure out where the vertices should be. The center is at 0, 0. Our a value is 4. That's the square root of the value under the x term. So we'll go a distance of 2 units. I'm sorry. We'll go a distance of 4 units to the left and to the right of our center point. So we'll have a vertex over here and another one over here. And our b value is 2, so if I go 2 units above the vertex and 2 units below, that will give us the edges of the box that we can create. So imagining some box like this. Our asymptotes will cross through. And we can build our curves. So there's our graph. Now let's list all of our attributes. So we said the center point is 0, 0. The focus points. So we need to find C in order to list those out. So let's use C squared equals A squared plus B squared. That means that C squared will equal 16 plus 4, or 20. That means C squared, or C would be the square root of 20, which reduces to 2 root 5. So that's the distance we will be, in this case, to the left and right of our center point. So I can imagine one would be at negative 2 root 5, comma 0, and the other one would be at positive 2 root 5, 0. And then let's list our vertices. So that will be based on our A value. So we were a distance of 4 units to the left and right of our center point. So one will be at negative 4, 0. And one will be at positive 4, 0. All right, so if given an equation, you can find your x and y value, or I'm sorry, your a and b value underneath x and y. It's starting with the x squared term, so that tells me that it's opening to the left and to the right, like what we have here. We can find out where our focus point should be by finding our value of c using this equation. And then we can graph by using our a and b values. And from there, that also gives us our vertex locations. So let's see our alternative orientation. So this is equation of a hyperbola still centered at the origin, but the transverse axis is along the y-axis. That means that it's opening upward and downward. And so notice in the formula, it starts with the y squared term. So they give us in example 3, 4y squared minus x squared equals 4. It should be equal to 1 to view it as a hyperbola to read the attributes from it. So let's divide everything by 4. That will give us y squared. It'll cancel with that 4, so I'll write this as y squared over 1 minus x squared over 4 now will equal positive 1. So just dividing everything by 4. So from here we could see that a squared will be positive 1, b squared will be positive 4, so that means a is 1 and b is 2. Let's go ahead and find c while we're here. C squared is a squared plus b squared, so 1 plus 4, which is 5. That means c will be, to take the positive square root, positive 5. So let's produce our graph. Our center is at the origin. Our A value is 1, and it's underneath our Y term, so that means our vertex will be above and below the center point. So I'd go up a unit and down 1 unit. That will locate our vertices. And then I will go to the left and right a distance of 2. That will be our B value. So that will tell me, oops, the edges of the box that we will create. So then I will visualize our asymptotes crossing through the box and through the center point. So that will make our hyperbola branch upwards and downwards. So there's our graph. Now let's list our attributes. So center is at 0, 0. Focus points, we would go a distance of the square root of 5, in this case above and below the center point. So that means it would be 0, comma, root 5 and 0, negative root 5. And then our vertices was a distance of 1 unit above and below our center point. So this would be 0, positive 1 and 0, negative 1. All right, now let's look at another example where we're just given some attributes and then let's build the equation and the graph. So it says to find the equation of a hyperbola that has one vertex at 0, 2, focus points at 0, 3, or 0, negative 3 and 0, 3. So that's all they're giving us. So let's use this to find the graph and the equation of our hyperbola. So it's helpful to visualize these points. So we have one vertex at 0, 2, so above the x-axis. Then we have a focus point at 0, negative 3, and 0, positive 3. So down here, and up here, 1, 2, 3. With just that one vertex, it would be hard to see or to figure out where the center point should be. But since we have both focus points, our center point should be right between them in the middle, which in this case puts us at the origin again. But in general, if this was shifted around and we were just given focus points, you can find the midpoint between them. So that means that our second vertex should be just 2 units below to make everything symmetrical. So this gives us two distances. From the center point to our vertex, that's our A value. So from this we can say that A will equal 2, or A squared would equal 4. And then the distance from the center point to the focus is 3 units. So that means that C is 3. So C squared equals 9. So let's use this to find our B value, because we're saying C squared equals A squared plus B squared. So 9 should equal 4 plus b squared. So b squared will equal 5. That means b will be the square root of 5. So that's again like a little bit more than 2. So that tells me how far I should go to the right and to the left of our center point. So just to get a rough sketch, I'll create this box, draw out the asymptotes. So our parabola, or our hyperbola, should look something like this. So now let's build our equation because we have our a squared and b squared values. So it's opening upward and downward, so that means y squared should come first. A squared is 4. Yeah, that should be a distance of 2. I think I left out a marker there on the axis. Yeah, I think I just accidentally erased that. So y squared over 4 minus x squared over b squared. B squared we're saying is 5 equals positive 1. So that will be the equation of our hyperbola. All right, let's look at finding the equations of these asymptotes of the hyperbola. So we have two different cases. Let's draw the two orientations. We'll still imagine that it's centered at the origin. So let's say this one will have vertices on the x-axis, this one will have vertices on the y-axis. So we'll have something like this. So the one on the left would open to the left and to the right, and the one on the right would open above and below. So on our left image, we're calling this distance, I should use red, this distance is A, distance to the vertex, so that means this distance B. So I could imagine this point on the corner, because I'm trying to, in order to give the equations of these asymptotes, I'm thinking of slope-intercept form, so I need the slope of the line. They're going through the origin since we're centered at 0, 0. So our y-intercept would be 0. So I just need the slope. So this point on the corner would have an x distance of A and a y distance of B. So that means if I was giving the equation of this asymptote, it should have a slope of B over A. So like rise over run. And then for the other one, it will just have a slope that is the negative version, negative B over A. So that means our asymptote equations here would look like y equals B over A times x, or negative. I'll just write them both as a plus or minus. I can say y equals plus or minus B over A times x. And then in our second case, we're just flipping what we're calling A and B. In this case, the distance is vertical to the vertex point, so that is our A. And then the horizontal distance will be B. So if I'm imagining a point here, this would be B comma A. So the slope of this line would be A over B. And the slope of the other line would be negative A over B. So in this case, for a vertically oriented hyperbola, I could say y will equal plus or minus A over B times x. So that's what they have here. I just wanted to show the visual version. So if x is first, that's when the transverse axis is on the x-axis. We get y equals b over a times x, or y equals negative b over a. And I need to specify that this is specifically when the hyperbola are centered at the origin. You could imagine these lines would have different equations if this has been shifted away from the origin, because we have the nice attribute that the y-intercept is 0, so we don't have any additional term. So then if y comes first, that means the transverse axis is along the y-axis. So our equations are y equals a over b times x, or y equals negative a over b. So I always just use the box that we create to help me imagine what the equation should be, what the slope of these asymptotes should be. So let's get some practice, working with a few examples. We're given y squared over 4 minus x squared, you can view that as x squared over 1, will equal positive 1. So I see y squared is first, so it'll open up and down. A squared is 4, b squared is 1. That means a is 2, b is 1. So let's find c. C squared is a squared plus b squared, so 4 plus 5, which is 5. So our c value should be the square root of 5. That'll help us label our focus points. So let's view the graph. Our center point is still at the origin. Our a value is 2, so I would go a distance up 2 units, place a vertex, then down 2 units, place our other vertex. Then to form the edges of the box, I would go left and right 1 unit. That's our b value. So our asymptotes should look something like this. So this corner point, that's the line. That's the point 1 comma 2. So that means the slope of this line should be 2 over 1, or just 2, because we go up 2 units over 1 unit. That's our rise over run. So that means the slope of this other line would be negative 2. So that will be useful. And then we can draw what our curve should look like. Now let's list our attributes. So the center is at 0, 0. Our focus points, we should travel a distance of the square root of 5, in this case above and below the center point, since it's vertically oriented. So we should have one at 0, positive root 5, and one at 0, negative root 5. Our vertices are at 0, positive 2, and 0, negative 2. Our a value was 2, so we went 2 units above and below the center point. And now we can give the equations of our asymptotes. So that will be y will equal positive 2 times x, and y will equal negative 2 times x. Okay, so pretty much same as before, we're just now adding this step of creating the equations of the two asymptotes. So let's see one more example like this. So we're given 9x squared minus 4y squared will equal 36. Let's divide everything by 36 so that it'll be equal to 1. So 9x squared over 36 minus 4y squared over 36 will equal positive 1. Let's reduce these fractions. 9 will go into 36 4 times, and then 4 goes into 36 9 times. So we'll end up with a 9 under the y squared. So here's our equation. Just kind of transformed it. So I see the x term is first, so it should open to the left and to the right. Our a squared value is 4, so that means a is 2. Our b squared value is 9, so that means b is 3. Let's find c. C squared is a squared plus b squared, so that will be 4 plus 9, or 13. So c will equal the square root of 13. Let's build our graph. So center is still at the origin. A is 2, so we'll go to the left and to the right 2 units since it's underneath our x term. We'll open up to the left and to the right. B is 3, so I'll imagine going up 3 units, get one edge, down 3 units, get our second edge here. Let's visualize the asymptotes. So our curve will open to the left and to the right. I'll go ahead and imagine that point is 2, 3. So that means the slope of this line should be 3 over 2, and then the slope of the other line should be negative 3 over 2. Okay, let's list our attributes. The center point is at 0, 0. Our focus points, that's a distance of c away from the center. This time they'll be to the left and right of the center, so we should have positive square root of 13, 0, and then negative square root of 13, 0. Our vertices, our a value was 2, so we go a distance of 2 units to the left and right of our center point. So positive 2, 0, and negative 2, 0. And then our asymptotes should have the equations y will equal our positive slope times x, so positive 3 halves x, and y will equal negative 3 halves x. Okay, now let's just generalize things to have a center point anywhere we want to. So a center point at hk. So just like with our other shapes with ellipses and circles, we'll see a minus h and minus k show up in our two formulas. Everything else will remain the same. We'll still imagine these distances from the center point, but our center point will no longer be at the origin. And we'll see how this will change how we'll write the equation of our asymptotes as well. So let's start with example 7. They want us to find the equation of a hyperbola with a center point at 1, -2. One focus point is at 4, -2. And one vertex is at 3, -2. So let's plot these and see what emerges. So our center point is 1, -2. So down here, we have one focus point at 4, -2. 1, 2, 3, 4. So over here, that means our second one. Well, let's start to list our attributes too. So from our center point to that focus point, that's a distance of 3 units. So that will be our C value. We'll go ahead and write that here. So that means our second focus point should be 3 units to the left of this center point. So 1, 2, 3 over here. Then we have a vertex at 3, -2. So 1, 2, 3, -2. So right here, vertex point. So that distance from the center to the vertex is 2 units. That's our A value. So I can say A will equal 2. So that means our second vertex should be 2 units to the left of the center point. -1, -2. Might be helpful to label these. So this would be +3, -2, and this is -1, -2. So let's find out what our B value should be, since C squared equals A squared plus B squared. So that means 9 will equal 4 plus B squared. That gives us B squared is equal to 5, or B is equal to √5. So that's again a distance a little bit more than 2. So just to visualize, I would go up a little bit more than 2 units, get the edge of my box, and go down a little bit more than 2. So here's our asymptotes. Now let's build the shape of our curve. So it's going to open to the left and to the right, since our vertices are to the left and right of our center point. So that means our equation should start with our x term. So that means we would have x minus h. If our center is at 1, 2, that means h is 1, k is -2. So that would be x minus 1 squared over a squared. A squared would be 4, minus y minus k. So y minus -2, that double negative will turn it into a plus. So y plus 5 squared. And b squared is 5, and this will be equal to +1. So there's our equation in our graph. We just have a shifted center point. Okay, last one asks us to analyze an equation, but it's all been multiplied out. So we'll need to modify it a bit before we're able to see what it will look like. So we're given negative x squared plus 4y squared minus 2x minus 16y plus 11 is equal to 0. So we're going to need to complete the square on both x and y. So let's first group the x terms together. That would give me negative x squared minus 2x plus 4y squared minus 16y. I'm going to move that 11 over to the other side. So it'll show up as negative 11. Now if you recall from last time, if we have some number in front of our squared terms, we need to factor that out of our expression. Meaning, I'm going to take that negative out and I'll have x squared plus 2x. And I'm going to take this 4 out and that will give me y squared minus 4y. Okay, let's produce our values that we want to introduce. So I look at this term, the 2. I take that number, divide it by 2, and then square it. That would give me 1 squared, which is 1. So that's the number I'm going to add inside my x parentheses. And then here we'll look at this negative 4. So I'll take negative 4, divide it by 2, and then square it. That would give us negative 2 squared, which is positive 4. So let's add these in the parentheses. It should be x squared plus 2x plus 1. I'm going to add the positive 4 in with the y's. But if you recall, we need to now add something to the other side of the equation in order to balance everything out. So we added a 1 inside here, but technically it's a negative 1 because it's being multiplied by that negative on the outside. So I'm going to add a negative 1. It'll show up as a subtraction, plus negative 1. And then similarly for my y's, I have a 4 that's added inside, but really it's being multiplied by this 4. So I'm going to add 16 to the other side. So both of these parentheses will factor into perfect squares. So this will give me negative x plus 1 squared. Then I have plus 4 that looks like y minus 2 squared. And then on the right, negative 11 minus 1, that's negative 12. So 16 minus 12 will give us a positive 4 left over. Now we have this negative in front of our x terms, so let's switch the order so we have our y term minus our x term. That will be in the form of a hyperbola. So I could say 4 times y minus 2 squared minus x plus 1 squared will equal 4. And then let's divide everything by 4, and that will give us our equation. So we'll have y minus 2 squared. We're dividing by 4, so it's going to cancel that 4 in front. So I'll just write it as being over 1 minus x plus 1 squared. This will be over 4 now, equals positive 1. So we used completing the square to turn it into a recognizable equation of a hyperbola. All right, so now let's define our attributes and produce our graph, and this time we'll even include the equation of our asymptotes. And notice the center has been shifted. So our a value, a squared is 1, so that means a is equal to 1. B squared is 4, so that means b is equal to 2. It's starting with y, so that tells me it should open up and down. Let's find our c value. C squared is a squared plus b squared, so 1 plus 4, which is 5. So c will be the square root of 5. That'll help us identify the focus points. Let's go ahead and produce the graph now that we have the equation. Actually, let me orient this a little bit differently since we won't be. Let's already define our center point. So it's h comma k. The h value comes from our x term. If it's plus 1 in the equation, that means it'll be minus 1 in our center point. And then the y part will be associated with our y value. I have minus 2 here, so it will show up as a positive 2 in the center point. So that's where we will orient things at negative 1, positive 2. So center point at negative 1, positive 2. Our a value is 1, so I'd go a distance of 1 unit, in this case above and below, since we're going to be vertically oriented. So this looks like the point negative 1, 3. And this would be negative 1, positive 1. Then to produce the box, our b value is 2, so I would go 2 units to the left and 2 units to the right. Let's produce the asymptotes. And then fill in our curve. So let's identify what the slope of these asymptotes should be. I can just imagine rise over run from the center point. So to get to this corner, I would go up 1 unit, that's our a value, and then over 2 units, that's our b value. This should have a slope of 1 over 2. That would make this line have a slope of negative 1 over 2. And let's just keep in mind that these both go through the center point. We can use that as a point, maybe in point slope form, to build the equation of our asymptotes. So let's list out our other attributes, our focus points will be a distance of the square root of 5 above and below our center point. So the square root of 5 will be added or subtracted to the y value of our center point. So that means we should have 1 at negative 1 and then 2 plus the square root of 5. And then our second should be negative 1, comma 2 minus the square root of 5. Then our vertices are and we have them labeled there. We can view it as a distance of 1 unit above and below the center point. So negative 1, 2 plus 1 gives us our 3, negative 1, 3. And negative 1 subtracting 1 will give us negative 1, positive 1, which was our second point here. So let's just give our equations of asymptotes as well. So I'm going to use the point slope form of an equation that looks like y minus y1 equals m times x minus x1, where we just need a single point and then the slope of our lines. So we can use the point as the center point since they both go through that one point. And then we have our two different slopes. So we have one that would be, our center point is negative 1, 2, so that would be our y1 and this would be our x1. So I can write it as y minus 2 will equal positive 1/2 times x minus negative 1, so it'll become a plus 1. Then our second equation will look the same. Y minus 2 will equal, in this case, negative 1/2 times x plus 1. So we can use the point slope form. If it asked for a slope-intercept form, I would still start here and then just distribute the slope through and then solve for y to get it into y mx plus b form. But I think we're safe to put it in point slope form as well. All right, that will be it for this section. So we are looking at hyperbolas with the center at the origin. We found asymptotes of the hyperbola, and then we shifted the center. The text has some application questions involving hyperbolas that are interesting and worth taking a look at if you want to check them out. All right, that will be it for this video, and I'll see you next time.